Picture this. It's 1908, deep, and I mean deeply hidden, in the remote Siberian wilderness. Suddenly, an explosion goes off that is so unimaginably powerful and devastating, it completely shatters the scientific understanding of the time. Welcome to The Explainer. Today, we're unpacking what is arguably history's greatest and most captivating scientific mystery, the Tunguska Event. Because trust me, the facts we're about to look at, they are absolutely stranger than fiction. Section 1. An impossible explosion, a crime scene without a cause. Okay, let's dive into this. Seriously, ask yourself, what exactly flattens 80 million trees without leaving a crater? This is the ultimate contradiction that sits right at the very heart of the Tunguska Event. I mean, think about it. When you have destruction on a scale that just wipes out tens of millions of massive, sturdy trees, basic physics tells us something huge had to hit the ground, right? You would absolutely expect to find a colossal hole in the Earth. But the Earth had a very, very different story to tell. To understand why this whole thing was shrouded in mystery for so long, we really have to look at where it happened. This was the incredibly remote Tunguska region in Siberia in 1908. We're talking extreme isolation here. It was a vast, sprawling landscape of dense forests with a very sparse population, primarily home to the indigenous Evenki communities. This absolute remoteness is totally crucial. It's the exact reason why an explosion of this terrifying magnitude didn't just instantly make front-page news all over the globe. It happened in literally one of the most secluded spots on the planet. Section 2. The Sky Catches Fire, June 30, 1908. The sheer speed of how this went down is just staggering. Eyewitness reports from that morning describe a sequence of absolute, unadulterated terror. First off, in a matter of seconds, this brilliant fireball dramatically tore across the sky. And this wasn't just a shooting star. It was a terrifying, dominant presence, even in broad daylight. Then, in a split second, there was a blinding flash of light. And finally, minutes later, a massive shockwave hit. That delay, of course, is just basic physics. Light travels way faster than sound in physical force. So eyewitnesses literally watched the sky explode minutes before the physical devastation actually reached them. And the kinetic energy of that shockwave, it was completely unprecedented. According to compiled reports, tremors were felt hundreds of kilometers away from the epicenter. We're talking about distant towns where windows were just suddenly shattered to pieces. The force of the blast literally knocked people flat on the ground, miles and miles away from those dense Tunguska forests. Just imagine that for a second. You're standing in your town, the ground shakes, windows blow in, and you're thrown off your feet by something happening hundreds of kilometers away. Wild, right? Section 3. A staggering scale, the aftermath. 80 million. It's honestly kind of hard for the human brain to even process a number that huge. But that represents the estimated number of trees completely flattened by the Tunguska explosion. 80 million individual trees in one of the densest forests in the world just wiped out, pushed over like they were nothing more than matchsticks. And those 80 million trees, they were spread across 2,000 square kilometers of absolute devastation. When researchers finally got around to mapping this area out, they noticed something super fascinating. The millions of downed trees were lying in a highly distinct radial pattern, pointing outward from a central epicenter. And as you might guess, it wasn't just the plant life that took a hit. The event caused massive, heartbreaking wildlife losses all throughout this enormous impact zone. Section 4. The 1920s Expedition, the First Detective. So because of that extreme isolation we were talking about earlier, this catastrophic event stayed pretty much unknown to the broader scientific community for years. I mean, after the blast in 1908, an entire decade goes by in the 1910s, where this remains virtually hidden from the outside world. It wasn't until the 1920s that a scientist named Leonard Kulik finally led the very first scientific expedition into the Tunguska region. The guy had to trek through absolutely unforgiving terrain just to reach the site of an explosion that had happened over 10 years prior. Section 5. The Missing Crater. Baffling Evidence. When Kulik finally arrived at the epicenter, he was ready to find the smoking gun. Any logical scientist back then fully expected to find a massive impact crater from a giant meteorite. Obviously, right? If an object from space knocks down 80 million trees, it has to hit the ground and leave a colossal crater. But the reality was a huge shock. Now, what's really interesting about this slide is the absolute contrast here. At the very center of that radial pattern of destruction, ground zero, there was no crater. None. Zero. Instead, Kulik found a forest of upright, heavily scorched trees, just standing there, dead center, looking like telephone poles stripped of all their branches. The trees all around them for 2,000 square kilometers were flattened outward, but the ones right in the middle, standing straight up. The evidence left at Tunguska was absolutely extraordinary. Kulik was staring at the aftermath of a blast that we now know was actually more powerful than many modern nuclear weapons. Yet, there was no crater, no large meteorite fragments, and absolutely no simple explanation for what had actually gone down. It was a complete and total scientific paradox. Which brings us to the ultimate question, doesn't it? If there was no crater and no massive meteorite, what on earth actually exploded over Siberia on that quiet summer morning in 1908? And perhaps even more terrifyingly, could something like this happen again? The facts we've laid out today really set the stage for one of the greatest debates in all of modern science. In part 2 of this explainer, we're going to dig into the wild scientific theories that attempt to finally solve this mystery. Thanks so much for joining me today, and I'll catch you in the next one.
Okay, let's dive into this. Welcome back, focused learners, to another explainer where we take complex historical mysteries and break them down so you can truly understand the facts behind the legends. Today, we're unpacking an event that literally flattened over 800 square miles of remote Siberian forest back in the summer of 1908. And get this, it didn't leave a single crater behind. We're talking, of course, about the Tunguska Event.
For more than a century, scientists have searched for one answer. What caused the Tunguska event? So what actually exploded over Siberia? Just to briefly recap the mystery for a second here. On a crystal clear morning in 1908, something detonated in the sky over the Tunguska River with just unimaginable force. I mean, it knocked people right off their feet hundreds of miles away. But when explorers finally made it to the epicenter years later, they found this completely bizarre scene. No giant space rock, no massive impact crater, just millions of flattened trees, all splayed out in this massive radial pattern. It left the scientific community with, frankly, a monumental puzzle.
Leading scientific theories: asteroids versus comets. You see, after decades of digging, scientists have basically narrowed the primary suspects down to two main types of space rocks.
For a long time, the debate really came down to these two. First, you have the comet airburst theory. Early on, some scientists thought a comet, which, if you think about it, is essentially a giant, fragile snowball of ice and dust, might have caused the blast. And that was a super popular idea, mostly because it perfectly explains why the object just seemed to melt away without a trace. But today, most scientists consider the asteroid airburst theory to be the leading explanation. Asteroids are denser, right? They're made of rock. The consensus leans this way because an asteroid's density just better matches the physics of exactly how deep this object was able to penetrate Earth's atmosphere before exploding. Now, sure, some specific details still remain a bit uncertain, but the rocky asteroid model just fits the hard data much, much better.
Now you might be wondering, how exactly does a giant rocky asteroid just disappear? Well, that brings us to a really vital concept, the airburst. This is an atmospheric explosion that leaves no impact crater behind. And guys, this is the absolute key to why investigators didn't find a massive hole in the ground in Siberia. The object came tearing into our atmosphere at immense speed, and the intense friction and pressure caused it to heat up and violently detonate midair, literally miles above the surface. So instead of a solid chunk of rock slamming into the dirt, it vaporized. It scattered microscopic mineral particles all over the region, like tiny little cosmic breadcrumbs that modern scientists eventually found embedded in the soil and tree resin.
And this brilliantly illustrates how we actually verify this theory today. Modern computer simulations confirm a massive atmospheric explosion. Using today's supercomputers, scientists can plug in all the variables. We're talking the blast radius, that weird butterfly-shaped pattern of the fallen trees, the lack of a crater, and those microscopic minerals, and the models perfectly replicate a stony asteroid airburst. The physics line up flawlessly with the physical evidence on the ground.
Measuring the destruction. The scale of Tunguska. Let's shift gears for a second and talk about just how terrifyingly huge this explosion really was.
5 to 15 megatons. That is the estimated energy yield in TNT. To put that into perspective, a blast of 5 to 15 megatons is almost unfathomable for a natural event. It's this colossal release of energy happening in a fraction of a second, creating a thermal pulse and a shock wave so powerful it literally circled the globe. It even registered on barometers as far away as England.
Let's anchor this against some known events to really grasp the magnitude here. The atomic bomb dropped on Hiroshima was about 15 kilotons. Tunguska was roughly 1,000 times more powerful than that. And even if we look at a more recent event like the Chelyabinsk meteor that dramatically exploded over Russia back in 2013 and shattered windows across an entire city, well, that was only about half a megaton. So Tunguska was on an entirely different, terrifying level.
Debunking popular myths. Fiction versus reality. Because, let's be honest, we can't talk about Tunguska without addressing the wild rumors.
You know, whenever there's a gap in human understanding, pop culture is just always eager to step in and fill it with some incredibly creative speculation. Over the decades, alternative theories have cropped up ranging from alien spacecraft and miniature black holes to secret weapons and antimatter. People have genuinely suggested a nuclear-powered UFO crashed in the taiga, or that a tiny black hole passed straight through the Earth. Others thought, hey, maybe Nikola Tesla was testing a wireless death ray in New York and just missed his target by a few continents. It's fascinating and honestly kind of amusing to see where the human mind goes when faced with an unsolved mystery.
But here is the reality check. These ideas are popular, but entirely lacking in convincing scientific evidence. They make for fantastic sci-fi, but modern science requires physical, measurable proof. And every single piece of physical evidence we have, from the treefall patterns to the microscopic silicates in the soil, points directly to a natural cosmic rock. Actually, to be totally blunt, there is absolutely zero evidence for death rays, antimatter, or alien engines.
Modern planetary defense, looking to the skies. So what are we doing today to make sure another Tunguska doesn't catch us off guard?
Well, thankfully, we are no longer blind to the universe like we were over a century ago. So the crucial point is understanding exactly what we are watching out for in the modern era, and those are near-Earth objects, or NEOs. These are asteroids or comets with orbits that bring them close to Earth. Today, astronomers and scientists all over the globe have cataloged thousands of these objects. Knowing where they are, how big they are, and where they are going is the absolute foundation of keeping our planet safe.
So how do we logically manage that threat? There are three primary steps. Step one is space monitoring programs. We have dedicated, high-powered telescopes scanning the night sky constantly, searching for absolutely anything moving against the backdrop of stars. Step two involves early warning systems. If an object is on a potential collision course, these networks immediately flag it for global astronomy teams. And step three is tracking hazardous asteroids. Once spotted, scientists track their trajectories years or even decades into the future to predict any potential impact long before it happens. So you can rest easy knowing we now have rigorous systems in place to track these threats.
Ultimately, studying Tunguska offers a really powerful reflection for all of us. Earth exists in a dynamic cosmic environment where natural impacts, although rare, are real. We are floating in a bustling, active solar system. Understanding these rare events matters immensely to our modern survival, because it reminds us that we have to keep looking up, studying our surroundings, and actively protecting our home planet. Which begs the question, if a rock that massive could slip by unnoticed in 1908, what else might be hiding in the dark, just waiting to be discovered?
More than a century later, the forests of Siberia have grown back, but the mystery of Tunguska continues to inspire scientists around the world. It remains one of history's greatest natural explosions and a powerful reminder that our planet is part of a much larger universe. This has been Mystery Vault. Until next time, keep questioning history.